Okay, hello everyone. Welcome back to our 10.2 na ngayon. So our lecture segment about fluids. Ngayon naman dadako tayo sa pressure or fluid pressure. Now let's proceed na. So when we say pressure, it is defined as the force per unit area. When the force is understood to be acting perpendicular to the surface area. So suppose that you have a surface area here. Hindi siya flat. Sorry. Assume mo na lang na flat siya. So that's gonna be like pag ganun yung x-axis, then pag ganun yung y-axis, pag ganun yung z-axis. Sige. Then there's a force na yung resultant niya pag ganito. Diyan sa surface area. So that F, yun yung force mo. And yung area nun nandito. So yung pressure na in-apply mo dun sa surface area na yon will be equal to the ratio of your force and the area. So P is equal to F divided by A, where the pressure has a unit of pascals. So we take note that 1 pascals is equal to 1 Newton per square meter. Of course, there are other units which we will talk about in the next slide. So let's first see this. So pressure is the same in every direction in a non-moving fluid at a given depth. So suppose now meron kang container dito and that container has a fluid. Let's say ganyan yung fluid. So lahat ng nandyan ay fluid na. Lahat ng nasa ilalim. And you randomly pick a point here. Sabihin natin dito ka pumili. You will note or you ma-observe mo na yung pressure from the left of that point is equal to the pressure from the right of that point, which is also equal to sa pressure from the top tapos yung pressure from the bottom. Tapos parang consistently na pare-pareho lang yung pressure dyan from all directions. And same din dito yung pressure dito. Same din dito yung pressure dito na na-experience doon is equal to the pressure na may experience dito. Kailangan natin take note that dapat nasa same level sila. Pag hindi naman daw constant or the same lahat ng pressure na na-experience ng point dun sa fluid, then that fluid will be in motion. So, familiar example dito is yung low pressure areas and high pressure areas. So, remember, mga typhoons ay low pressure areas. Diba? So, kunwari ganyan, ito yung I. Excuse me. And yun yung parang mga tails. So, sa loob kasi nun, yung I mismo is a low pressure area. And everything inside here is a low pressure area. On the other hand, yung nasa labas, lahat na nasa labas are normal pressures. So relatively speaking, these surroundings have a higher pressure gradient or pressure area, are high pressure areas. And ang mangyayari ngayon is that yung pressure gradient ng dalawa, yung difference ng pressure will cause the fluid to move from the high concentration to the low concentration, or sabihin na natin from the high pressure to the low pressure area. So ganun yung principle dito. High pressure to low pressure yung motion ng fluids. So let's also take note of this second bullet. Other units for pressure primarily used in meteorology include the atmosphere. So 1 atmosphere is the pressure at sea level. So this is at sea level. Hindi naman kita, pero sige. The bar and the millibar. This is equal to 100, I guess, na kilopascals. I-search nyo na lang to verify. The pounds per square inch, which is the US customary system. And the Torr, which was named after Torricelli. So yung Torr is, so suppose meron kang ganito. This is what you call, this is a schematic of a barometer. And yung barometer mo yun, merong mercury. Ayan. So, suppose that yung mercury mo has a, sabihin na natin, what do you call this? Yung displacement nun, o yung parang delta H nun, is equal to 1 millimeter. So, it means to say, kung 1 millimeter yon, then the pressure being applied on that mercury by the atmosphere is equal to 1 millimeter of mercury, which is equal to 1 torr. So 1 millimeter of mercury is equal to 1 torr. Okay. Here naman, let's talk about the relationship between the pressure and the depth. So when we say, when we speak about this thing, we do take note that the pressure is directly proportional with the depth. Meaning to say that at deeper depths, inside the fluid, mas malaki yung pressure. So yung pressure dito sa surface is P sub 0, and the random point with depth H, or Y pala, P, yung pressure dyan, P. So itong distance from here to here is the H. So yung pressure daw dito, P, is equal to the surface pressure. Minsan atmospheric pressure siya, pero it depends on the context, plus this product, the density of the fluid raw times G, the gravitational acceleration. Neglect natin yung yung possible implication pag sobrang lalim na. Pero since hindi naman ganun ka-significant yung difference, then we can assume G equals 9.8. Of course, meters per square seconds. And your Y being your depth, H. So H is equal to Y. And we do take note that ang magiging unit ng Y, magiging sign ng Y will be positive downwards and negative upwards. Since we're talking about depth and not height. So next. So the pressure difference between 2 points in a fluid with uniform density, again, uniform density. So ang density from the surface, tapos all throughout the fluid, pababa is uniform, is proportional to the difference in elevations. So meaning to say that delta P, so this is just the equation here, delta P is just equal to rho times G times delta Y. Actually, wait. Itong rho times G is also, kung marirecall nyo sa pinag-aralan ng first part na lecture, it's also the weight density of the fluid. So yeah, so it's just the weight density times the difference in depths. Okay? Okay. Now we have what we call the hydrostatic paradox. Kung sinasabi dito yung hydrostatic paradox, suppose that dito sa height na to, so assume na natin na level yan. Hindi gaano kaganda yung drawing. Actually, ulitin ko yung drawing. So, yan, sige, assume na natin na level yan. Yung pressure daw at that level will be consistent or will be equal to each other. So regardless of the shape of the container, the same lang ang pressure dito, 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 saka dito. So yung pressure na ma-experience ng at that point from the fluid will be consistent in a level despite the different widths or the shape of their containers. So this means that the pressure is independent in the shape of the container. And this paradox also proves that water or fluids in general seeks its own level. So kaya kahit anong gawin mo, magle-level talaga yung fluid sa kanilang container despite of the difference of what do you call this? Shape. So iba na lang kung like nag-aralan niyo osmosis, iba na yan. Out of the scope. Anyways, let's go. Now we have what we call the Pascal principle. So ang Pascal principle, named after Pascal, syempre. A pressure change applied to a confined fluid is transmitted undiminished. Again, transmitted undiminished to every point in the fluid and to the walls of the container. So again, suppose na meron tayong container dito and we have like ganito. This is a schematic of a hydraulic press. If you're familiar, ito yung ito yung nakita niyo sa YouTube na pinipipi yung can or something else. Or kung ano man meron kayo dyan. Kung meron kayong hydraulic press. Anyways, so this is the smaller piston and this is the larger piston. The pressure you applied upon this part, so that's gonna be pressure P, will be transmitted undiminished. What do you mean? So mag-transmit siya all throughout the fluid in a consistent manner. So ang pressure na ma-apply dito will still be P, this will still be P, this will still be P. And yung output pressure will also be P. And thus, this means that for hydraulic presses, ganito yung magiging pressure. So the pressure is equal to the pressure at this piston, which is also equal to the pressure at this piston. Again, what's our definition of pressure? This is the force divided by the area. So the force that you applied on this part divided by the cross-sectional area of this piston will also be equal to the force that is output on this part divided by the cross-sectional area of this piston. And we also have what we call the mechanical advantage. A mechanical advantage, this is in machines, I guess. Ito yung measure of how much output from an input. So suppose that you have yung mechanical advantage ng machine mo is 4. It means that if you applied a 1 Newton force to that machine, it will output a 4 Newton force. Ganun. So parang machine talaga siya. 1 Newton, okay, 4 Newton. Ito yung mechanical advantage or the ideal mechanical advantage. So that's equal to the force output divided by the force input, which is also equal to the area output divided by the area input. So this is output. Now this is input. Tama eh. So ganyan yung magiging parang formula for Pascal's principle. Again, yung Pascal's principle, transmitted and diminished. Okay, let's now actually go to here. We have what we call the gauge and the absolute pressure. Pag sinabi natin gauge pressure, ito yung pressure relative to atmospheric pressure. This means that at 1 atm, gauge pressure is 0. At 2 atm, ang gauge pressure is 1 atm. Since you're just gonna subtract 1 atm since hindi naman siya atmospheric, yun yung atmospheric pressure, di ba? At sea level. Sea level. Then atmospheric pressure is the pressure exerted by the weight of the atmosphere. At sea level, exactly 101.325 kilopascals. Or that's also equal to 1.01 times 10 raised to 5 pascals. Neglecting this other part, syempre. And we do take note that the absolute pressure will be the exact pressure experienced by a body on some part, which is equal to the atmospheric pressure plus the gauge pressure. So yung absolute pressure is the actual pressure, the atmospheric pressure is the pressure at sea level, and the gauge pressure is the apparent pressure relative to the sea level pressure. Let's take note of this. If the pressure inside a car tire is equal to atmospheric pressure, the tire is considered flat. It is because, so suppose ito yung tire mo, pag nabutasan yan, mag-i-equalize yung pressure input and pressure output. And thus, magiging flat yung tire mo, syempre. Okay, now let's proceed to the problems. So for the first problem, or the third problem of this lecture, what would be the height of the atmosphere if the air density were uniform and decreased linearly to zero with height? So let's assume that at sea level, air pressure is 1 atmosphere. And the air density is 1.3 kilogram per cubic meter. So, ang letter A muna sasabihin natin what if it's uniform. So, we do take note kanina that uniform density, it means to say that uniform density. So, suppose na may fluid ka dito. And, ito yun. So, this will be the sea level. This is all air. And this is the height of the atmosphere. So, let's say this is the roof of the atmosphere. And the height of the atmosphere will be h. So we'll talk about this in terms of depth. So y is equal to h. And this is our point 0. And this is our point h, of course. So we have initial pressure. So ang pressure dito will be equal to 1 atmosphere, which is equal to 1.01 times 10 raised to 5 pascals. Whereas here, pressure at the roof of the atmosphere is 0 atmosphere. That's also equal to 0 pascals. So we are finding the height when it is uniform. So we can just use the usual formula. Hindi pala makita ng mayos to. Usual formula, that is P is equal to P sub 0 plus rho G Y. So our P here is 0 atmosphere. 0 pascals is equal to 1.01 times 10 raised to 5 pascals. This is in pascals, so we're using the mismong units. Or we're using the SI units. Plus, ano yung density? We have this density, 1.3 kilogram per cubic meter. So we're just gonna use that. 1.3 kilogram per cubic meter times ano yung G, that is 9.8 meters per square seconds. Times ang depth nito, which is the height of the atmosphere. So ang gagawin natin dito is do some manipulation. Yeah. Since height, wait lang Bakit? Yeah. Anyways, ang height will be the depth. No. No, mali pala. So, mali ako, sorry. That's why. Ang P pala natin is yung 1.01. So that is 1.01 times 10 raised to 5 is equal to 0 plus this value. So since 0 naman to, kakancel na natin to. To find H, we're just gonna divide by the product of these two. 1.3 times 9.8. Cancel to means that the left hand side of this equation will be divided by that value. And thus, your height H is equal to, that's 101, 1.01 times 10 raised to 5 divided by 1.3 times 9.8. So that is 7.93 times 10 cube meters, which is also equal to 7.93 kilometers. Yes, that's the answer for letter A. Okay. Observe nyo muna kung paano yan nangyari. Okay. Next, what if it decreases linearly to 0 with height? So again, may schematic dapat tayo para exciting. This is at sea level. This is the roof at the atmosphere. And measure H. This is Y equals H. Ang pressure sa taas is 0 atm. And pressure sa baba is 1 atm or 1.01 times 10 raised to 5 pascals. Now, sinasabi dito the density decreases linearly to 0 with height. So, pag pataas na ng pataas, pababa ng pababa ang density. Let's have a like a graph here. Ang galing. Again, let's have a graph here where the x-axis is your depth and the y-axis is your density. So, mangyari daw dito is as you go down from the roof, kasi sabi dito as you go up from the sea level, nagdi-decrease linearly to 0. Pero if as you go down from the roof, kasi dito ang density dyan is just 0. And thus, magiging 0 ang density at y equals 0 then. At y equals h, ang density niya will be 1.3. So this is 1.3. And this is h. Linearly, sinabing line yan. So this part will be a triangle. Hindi siya, wait lang, hindi pala yan yung hinanap natin. We're finding the relation between the y and the rho. So we know that through like similar triangles, yeah, like similar triangles pala tayo. We have this. That's the height, and we have this. This is the 1.3 density. So we have like ano ba to? We have like a relation that the density is equal to k for a constant or the slope times y. So let's find the slope, that is k is equal to the density rho divided by y. And at sea level, so that is h, and density at sea level is equal to k times h, and therefore k is equal to the density at sea level divided by the h. So equating these two case, we have the density at the density divided by the depth is equal to the density at sea level divided by the height of the atmosphere. And thus, the density, bakit yung density later on malalaman natin, is equal to the density at sea level times the depth y divided by the height of the atmosphere. Now what? Yun yung gusto sabihin. Now what? Ano naman? So we do take note kanina that the pressure, so ito na equation, the pressure is equal to the initial pressure plus the rho times the g times the y. However, the rho kasi is, what do you call this? This rho is constant here or uniform. So you're gonna differentiate this in terms of with respect to the height. Since the pressure will now vary, so that's gonna be dP divided by dy is equal to, since pressure dito is just yung initial pressure is a constant, that will be 0 plus rho times g. So we have rho here, which is here. Ito yung rho, di ba? So we're gonna substitute it. So we will have the rho at sea level, which is a constant, times the y over h divided by g. Now we're gonna integrate it with respect to y. So that's dp over dy. Actually, dapat i-multiply muna natin bago natin i-integrate. So that's gonna be dp. Nag-iba naman ang kulay. AC equal to rho sg over h times y dy. Now we're gonna integrate this both sides. So initial pressure dito is 0, and the final pressure will be this one. So that's gonna be P na lang. On the other hand, ang initial height or initial depth is 0, and the final depth is RH. So that's gonna be pressure P is equal to, since this part is a constant, we're just gonna copy that. Rho at sea level times G divided by H times 1/2 y squared. We have P. Since y squared, ang mangyayari dyan, that's from 0 to h. So that's just gonna be 1/2 of like h squared minus 1/2 of 0 squared. Yung 0 magka-cancel naman, we just have h squared here. Magka-cancel lang isang h, and we want to find the height, of course. So ang mangyayari ngayon is that tatanggalin ko na itong isang part. Mangyayari ngayon is that, come on, okay. H, isolated na H is equal to twice of the pressure at sea level divided by the density at sea level times G. Substitute the values, we have 2 times 1.01 times 10 raised to 5 divided by an density at sea level, that's 1.3 times G, which is 9.8. Neglect mo na lang yung height differences, and that will be 1.59 times 10 raised to what? 4 meters, which is also equal to 15.9 kilometers. So that's our answer for letter B, problem number 3. Okay. So i-absorb lang muna kung paano nangyari yan. So this one is actually since ito kasi is not constant, diba? So we're just gonna substitute. Yeah. Okay. Now let's proceed to the next problem. For problem number 4, a pistol of cross-sectional area little a is used in a hydraulic press to exert a small force of magnitude little f on the enclosed liquid. A connecting pipe leads to a larger piston of cross-sectional big A. For letter A, what force magnitude big F will the large piston sustain without moving? And letter B, if the piston's diameter are 3.80 centimeters and 5.30 centimeters, what force magnitude of the small piston will balance a 2,000 kilonewton force on the large piston? Let's have a schematic na. So a small piston here, my fluid dyan, and a large piston. We have a small piston here. And we have a large piston here. And lahat ng nandito is fluid. Okay. So that small piston now has a cross-sectional area of little a, while itong malaki may cross-sectional area na big A. And you apply the force here. Ang tawag dito? A small force now of magnitude small f or little f. So my output pressure ngayon na big F. Or actually, to balance things out, let's use the other direction. Yeah. So first, what force magnitude F of the larger piston will sustain that thing? So for letter A, mangyayari dito is we're just gonna use the Pascal's principle. So we have small f over small a divided by big F over big A. We're just finding the magnitude of F by isolating big F. So big F is equal to big A small f over small a. So that's literally it for the first part of this. And for the second part, for letter B, we have again the Pascal's principle. However, binigay sa atin 3.60 cm and 53 cm. So let's have here. For the small piston, yung cross-sectional area A is equal to pi r squared, diba? Pi r squared. And our r is half the diameter. So we have pi times small d over 2 squared. Or that's just equal to pi small d quantity squared divided by 4. On the other hand, we have big A here. So ganun pa rin, ang area nito will be just pi times big D. Pag small d, small diameter. Pag big D, big diameter over 4. So we'll just use again the Pascal's principle here. So again, small f over small a divided by big F over big A. We're finding the force on the small piston. So we're isolating small f, that's gonna be small a times big F over big A, which is equal to, ano yung nakuha natin dito? That is pi times small d quantity squared over 4 times big F over pi times big D quantity squared over 4. Pagka-cancel ang pi over 4, so that's gonna be d squared F over big D squared. Ano yung small d natin? That's the smaller diameter. So that's 3.8 centimeters. I'm not really gonna convert it anymore since para namang silang centimeter and that will cancel out. So 3.8 quantity squared times, ang force natin is 2020 kilonewtons divided by 53 quantity squared. And that results to, again, so we're gonna 3.8 squared times 20 divided by 53 squared, that is 0.1 03 kilonewtons, which is also equal to 103 newtons. So both answers are acceptable unless stated otherwise. And that's it for our second part of the lecture. And for the third part, pag-aaral naman natin ang buoyancy. So just stay tuned or manood na kayo next. But for now, this is it. Thank you for watching.